Hello, everyone. This is Ali Lazim from Medixbot. I'm the CEO and CTO of Medixbot. I'm thrilled to share with you my insights about the artificial intelligence, especially some of the sophisticated AI technologies that's actually creating a revolution in the healthcare. And today we'll be more focusing on enabling physicians to build custom conversational AI agents to make the understanding of medical knowledge, terminologies, and also support data-driven healthcare decision-making systems. So first of all, actually, I would like to go over in a brief on the technologies that I just mentioned that will be focusing during this session. The AI, artificial intelligence in healthcare, actually, we have real advancement in using the foundational large language models. That will be built on the top of the foundational large language models. We have the conversational AI, generative AI, prompt engineering, and we'll be actually going over the four main methods of prompt engineering: RAG, React, Code, and DSP. That's actually enabling us from avoiding fine-tuning or using pre-trained large language models and enhance them or train them on a specific domain. Then we'll be moving on to talk about the knowledge graphs, vector database, cognitive search, multi-agent systems, and also how the short and long-term memory is helping us in building such intelligent copilot and agents. So first of all, to start with the large language models in healthcare, we have a lot of open source and application now in the market that actually trying to solve some of the problems in healthcare using the large language models. There is two main directions within those applications and systems. Some of them, they are trying to build custom domain-specific language models. Some of them, they trying to fine-tune the large language models, the pre-trained large language model, especially the open source of them, like the Llama. Also, there is another direction that we are actually trying to do and working on that, and we believe that's the best solution for that, is that to use the foundational large language model without fine-tuning them, but to build another technologies on top of it that will interact with it, like the prompt engineering that we mentioned, to deploy one or implement one or more prompt engineering methods, to use the different utilities and tools to be interacted with the LLM. That will be more about actually enhancing the responses of this large language models and make this large language model focus on the specific domain. So instead of we fine-tune the large language model to be focused on a specific domain, we trying using the tools and the prompt engineering to make the large language model be able to focus on that model and generate more accurate and retrieve more accurate information for us. We will be using the existing foundational modern large language models. It is a crucial part in any AI system currently. So we will have also, our demo today will be including also, we will be actually guiding you through the process of building an application, AI application by yourself, even if you are a non-technical person. So we'll be showing you how you will be handling the natural language understanding and generation. So the large language model has a lot of advantages. In addition to whatever we mentioned, on top of that, it's also helping in the clinical decision support. and it's actually a key enabler for AI in healthcare. Going forward, actually, I would like also to talk about the conversational AI and its role in healthcare or healthcare AI-based applications. So when we use the conversational AI, actually, it's increase the patient engagement, enhance the patient engagement with the system, since it will be communicating with the system in a natural language way, and both in text, audio, or even sometimes with video. Also, it's supporting not the patients only, also the professionals, and increase the usability of the AI application to be used in very easy way and usable way by the professional, like the physicians. The good things about them, they are always on. So it's not like you have a system that sometimes they are off and you need to have them. So they are with you all of the time. This will enable us from customize and personalize the healthcare and the communication between the patient and the AI system and the physician and the AI systems. Those will be powered by the LLM, as we talked about. That's everything will be powered by the foundational LLM, that will be building on top of it everything almost. This is increasing the accessibility, of course, to this application. Again, we will go over another one. There's another AI technology that will be involved in our system, open source system, that we'll be sharing with you within this session. It will be the generative AI. So generative AI role in healthcare actually is very important because it's enable us from in the healthcare now, we're trying to move into personalized healthcare in general, because we believe that not every person has the same need the same cure, or has the same having the same symptoms does not mean that they will be give the same responses to the same cure or treatment plans. So this is why using generative AI, understanding and learning the patients themselves, looking into the records, comparing all the data for them and also for the other patients, will help us introducing and building personalized treatment plans. It's not just treatment plans, actually. We'll be able to build all the plans that can, or the programs that we are offering down for our patients. Even it's not just about health, we can offer a personalized diet program. We can offer personalized workout program, for example, for their physical activities, depending on their illness or their symptoms. Also, that's really very important. Generative AI play a very key role in generating actually synthetic medical data. Synthetic medical data is very important for us because not all of the time we are really reaching or have access to the big data that we need to train our, for example, machine learning models. So this is why we are using generative AI to synthetic the medical data and actually also augmented it. We will be, actually the generative AI will be learning the documents and use the documents or the knowledge base, structural and unstructural data in actually building and retrieving information and generating information, building on the top of the existing structural and unstructured data. We will have a predictive insights about the patient situation, the treatment plans. We need to really here focus on the fact that whatever the system that we are building, I'm not talking specifically about generative AI, but in general, any AI in healthcare should take care of about the patient privacy, physician privacy, and also the ethics of the system that we are building. Moving forward, we talked about the prompt engineering. So we'll be introducing also prompt engineering as an alternative solution to not fine-tune the large language model, but instead to use the foundational large language model as it is, but with the prompt engineering like RAG, retrieval augmented generation, or the chain of thoughts, or the reason and act, react, or the actually directional stimulus prompting, DCP. So those four main methods could be used in enhancing the information retrieval from the AI. So many will be focusing on RAG, and we advise you to start with one of the systems. RAG is really very appropriate for healthcare applications, but you can extend it later on by adding actions on top of the RAG. So you will be moving to the React. Then you can also combine it with the code or with the DCP. So with COT or DCP. So why will be actually adding to such a system the RAG? The RAG will be actually giving us will be consisting of domain healthcare knowledge base. So instead of we get benefit or we send our prompt to query all the data that large language model learned with this billions of parameters and factors around the world, we will direct it to focus on that specific domain that we are interested in. So this is one of the main components of RAG, that's to define to build a knowledge base as the main data source for LLM to be answering our queries in the focused way, in accurate way. Then we will be using the generative integration with the foundational LLM that will generate that content depending on the knowledge base. So actually RAG offering knowledge base, so to help enabling the LLM to focus on that knowledge base or that domain. But actually we continue using the advantages of LLM by the generative part of LLM. So it will be use its capability of understanding the prompt and also generating useful information, but from data and information specifically focused and within that knowledge base, not outside of that knowledge base. This is why RAG is really very important to increase the accuracy and actually the focus of the information that we are retrieving or the responses that we are getting from the AI system. Knowledge graphs in healthcare. So I would like to go over these things to not explain them in very details. So knowledge graphs is actually it's about the relationship between the learned information. So the most important here, why we give very importance to the knowledge graph in healthcare, because we need the knowledge graph to build the relationship, for example, between symptoms, diagnoses, and treatments. So we'll be using the knowledge graph instead just relying on the regular databases or on the vector database. But we'll be also using the vector database in healthcare because it will be embedded most of the data and it will be scalable, because we cannot use knowledge graph for everything, for especially big data and huge data. So we'll be using the vector database and the knowledge graphs in actually integrated way, in a specific logic and specific pattern. So vector database actually helping us running the similarity search, semantic, to find which concept, which vectors they are more close to each other, and is scalable. Cognitive search in healthcare, we would like to introduce all the huge documents that we have in AI, whether they are belonging to our clinics, to us as physicians, or it's about the healthcare in general or medicine in general. We can provide it to the AI system, and the AI system will be learning them and actually will be there answering us from them. But our cognitive search will be supported with citation. So when we get information from our cognitive search, we will know from which source we retrieved that data, and it will be also we will be giving importance to the data governance. Healthcare multi-agent system. Since we believe that one AI agent or one AI copilot cannot do everything, actually it will be more facing problem like hallucination or facing other problems that it's not give exact data for some of the different domains that they are not focusing or not trained on it. So this is why we believe that the system should be built as multi-agent system. So we have one agent for each domain, and there will be one master agent in the mass system that will be coordinating, finding the intention of the patient or the intention of the physicians, and direct the request or the prompt to the correct or the sophisticated agent. And that sophisticated agent will be using the tools that's connected it to give the right response. And maybe sometimes the master agent may trigger and classify the request into multiple agents, collect the response from agents, and give one responses to the user. None of the whatever we talked about will be really possible without using the short and long-term memory, because it's using the short and long-term memories. Actually, it's helping us in understanding the context, remembering the context, remembering the user and the information that we got of them, and depending on the usage, we sometimes keeping those knowledge or those data into short terms, sometimes into long term memories. So now we went over all the concepts or sophisticated AI technologies that we would like to introduce. All those technologies will be integrated and combined in order for one goal, to develop a custom virtual assistant copilot for the physicians by implementing and deploying a swarm of agents. So we would like to introduce the Medixbot copilot. That will be actually introducing to you. You'll be able to build it. It's an open source, by the way. It's on GitHub. Will be released in the next 1-2 months, and everyone has the access for it. And you can download it and you can customize it, personalize it for your need and for your domain. But this Medixbot copilot actually will be increasing and enhancing the goal from it, the main goal, enhancing the clinical efficiency, enhancing and helping the physicians in doing their work, and also enhancing, actually helping the patients to be able to express themselves, tell their situations, their symptoms in more sophisticated way and in more natural way. Even the other side is not a human, is an agent and digital agent. So building an open source tool will be built with, you will be able to build actually using our open sources tools. Our open source also actually rely on open source existing in the market. So we are using an open source LLM, conversational AI, all these things is actually open sources. We collect it up, we develop one open source code. So you don't need to develop a code. You just need to customize and configure this for your domain and for your need. So the open source Medixbot copilot system that we built actually has an LLM, foundational LLM inside. You can select, there's a few of them, you can select one of them and configure it. We have a conversational AI chatbot built ready for you. You don't need to develop an UI UX for it. We have a generative AI components, prompt engineering. We focusing currently RAG, but we promise you in the next versions we'll be introducing and combining also adding actions. So we extend it to React and also combine it with the other prompt engineering methods. We'll continue enhancing the systems. Currently is also existing, has the knowledge graph that you can add your knowledge there, vectoral database that you can embed your data there, cognitive search that work on both structured and unstructured databases. And we have the multi-agent system that will have multiple and a swarm of agents controlled by the master agent. And all these will be using short and long-term memories. So this is the system. This is very generic, very top level architecture for the system. As you see, the patients, the physicians will be communicate with the conversational AI chatbot. For example, patient, they will be telling their symptoms, conversational taking the notes of that, trying to give it guesses, ask following questions to get more information about the other symptoms that the patient forget to tell about, or actually that's the system need to know more about it. Then it will give it to the Medixbot swarm of agent, the master agent, to understand what's this request about. Also the same for the physicians. They will be asking and giving requests to the conversational AI by speaking to it, hearing it, or by writing and reading the responses from it. Then the master agent, as you can see, it's actually controlling the multiple agents. We have the generative AI and foundational LLM. We have the prompt engineering in the system, and we have the keyword catalog. So we, as you can see, we are using different methodology depending on the type of the process that in the flow that we are using. So for example, sometimes for some prompt, to find the intention from that prompt, we can do string matching by going to our keywords catalog. But if this not work, then we go to the vectoral database, try to find to do the semantic similarity search. If not, then we go to the knowledge graph to find the relationship between the concepts, and so on until we find the intention of the patient or the physician. So this is step by step that I will go really very fast on it because we already explained most of the concepts here. So we are advising you to go over the following steps, that you define the scope and functions for your agents. Don't forget that those agents learn, retrieve, and act. So you need to build it for a specific domain, and don't build something very big. Try to build the core thing, the focus things, and then you enhance it and extend it by building other things. This will help you to focus more on to get better result. So the Medixbot agent that will be used, we give an example that, for example, you can use it for symptom collections, as I mentioned previously, or to use it for knowledge extractions about healthcare, or as an AI recommender may be helping you in diagnosis or other things, or suggesting treatment plans. It can do the cognitive search all your structured data. It's access your application that you are using in the clinics. Extract data from them, then combine it with other sources and give it to you ready as an answer for whatever you are looking for or whatever you are asking. You'll be able to build workflows and task automations and actions. So the agent is not just giving you information, but those agents could be run automation autonomously and do some tasks instead of you, especially your daily tasks that it's not need your experiences, and it's safe to be run by agents without your intervention. So the second step, you will be setting your language model. As we said, here we are suggesting some of the tools, like you can go to the Hugging Face Transformers library and select one of the LLMs. Then you need to also do your conversational AI for the interaction. There is ready like Grok, like Rasa. We actually integrated. You don't need to set it, by the way. You just need to set your key, and that's automatically you will have the chatbot with its interface supporting audio and text. Then the generative AI component is also you can select from Grok and also other options to be built on top of ChatGPT, GPT-4 or other one. We have the rank system built for you. So you can select it and actually you can provide it with your knowledge base. Then the knowledge graph also it's built there. You can use the Apache Gina for RDF, or you can use other one for the as a knowledge graph like the Google knowledge graph, etc. Vectoral database, we are using Pinecone inside our open source, but also you can set the Milvus or any other vectoral database. Then the multi-agent system is you can use the existing one. Also, we have our own multi-agent system. So you can use the default one, ours, or you can replace it by AutoGPT or other ones. So the conversational AI and chatbot interface, actually, you can build it with, we are using and building, giving you two options, the chain-lit one or the stream-lit one, but you can add other ones. So the implementation step, as I said, we advising you to be really focusing on core functions first, and then you extend it. Feel free to access our GitHub account and follow up with our announcement until we're releasing this complete open source. So for the future of health care AI, here we are working as Medixbot and me with all the experts in this domain to bring the potential of hybrid intelligence in healthcare. And this is to advance the healthcare with this AI revolutions. We believe that the future will be in adopting AI systems in healthcare. And stay tuned, please, for the coming healthcare swarm of agents from Medixbot. Thank you very much.